In a new twist to waste-to-fuel technology, scientists at the Department of Energy's Oak Ridge National Laboratory have developed an electrochemical process that uses tiny spikes of carbon and copper to turn carbon dioxide, a greenhouse gas, into ethanol. The team used a catalyst made of carbon, copper, and nitrogen and applied voltage to trigger a complicated chemical reaction that essentially reverses the combustion process. With the help of the nanotechnology-based catalyst, which contains multiple reaction sites, the solution of carbon dioxide dissolved in water turned into ethanol with a yield of 63%. The catalyst's novelty lies in its nanoscale structure, consisting of copper nanoparticles embedded in carbon spikes. This nanotexturing approach avoids the use of expensive or rare metals such as platinum that limit the economic viability of many catalysts.
Here at the Center for Nanophase Material Sciences, we're using nanotechnology to study how we control chemical reactions on catalysts. We were actually studying how to take carbon dioxide and convert it to what we thought was going to be methanol. It turned out to be ethanol, which was very scientifically interesting, and it was unexpected because we didn't think the catalyst we're working with would do the entire reaction on its own. We originally started trying to grow a type of catalyst based on a material called graphene. And as it turned out, with the equipment we have, we couldn't make graphene, but we could make these little tiny spikes. So these little spikes are actually like tiny lightning rods. And so they actually taper down to a tip that's just a few atoms thick. And what that does is it concentrates the electric field right there at the tip and creates a very high electric field that you wouldn't get on a normal flat catalyst. One of the nice things about this catalyst is it actually has a yield of around 63-65%. We've measured as high as 70% depending on the sample, which means that of all the carbon dioxide and all of the electricity that's going into it, you don't waste much of it. The majority of it ends up actually converted to ethanol. It matters technologically because ethanol is a fuel. You can use it in the current vehicle fleet right now with no modifications. CO2 or carbon dioxide is a problem right now, and if you can use it, then you're preventing it from going to the atmosphere. And because this reaction operates at room temperature, it can be turned on and off very easily with no real energy penalty. And so we see this as a way that you could store extra electricity from the grid. Typically, the grid is destabilized by variable sources like solar and wind. And so there's a limit to how much variable electricity or variable sourced electricity we can put into the grid. If we could have a variable load that would be turned on and off at will, then it gives us a way of actually sucking that electricity up and using it.